right, so let's welcome to our last session. So our first talk in the last session is from Ida Surakka, and she will talk about the importance of collaboration.
Okay, so hi all, Ida Surakka from the Department of Internal Medicine. Kind of in the perfect spot to talk right after Ben, because he kind of gave the motivation for my talk without me actually going into it that much. I did have an idea to start with the why do we need collaboration, but I'm gonna kind of skip into this one, just saying that power is everything when we're looking at common disease genetics. So in order to achieve that power, obviously we cannot, collect millions of samples in one location. So the fastest way to get us there is through the collaboration, which allows us to, have the sample size. So in order to show you kind of like how MGI is part of these large global research consortia, I have two examples that I'm gonna run through. One is the Global Lipids Genetics Consortia, and the other one is the GBMI that Ben already kind of shortly mentioned in his talk. Obviously, these are not the only consortia that MGI is part of. MGI is very actively collaborating globally in different traits and diseases. These just happen to be the one that I am very actively working in, and they are the most common for me. So Global Lipids Genetics Consortia was originally funded by Zach Catherison and Kristen Wheeler as a collaboration between the Broad Institute and University of Michigan. Obviously, both of them have now moved towards new venues, and the leadership is nowadays led by Pradeep Natarajan and Gina Peloso from Broad and Boston University. So in practice, we have a very dense GLTC core group that is sitting down frequently, updating the analysis and ideas around this consortia. Very diverse backgrounds, and also we are kind of like clustered in different parts of US and the world. So kind of like where GLGC started back in the day. So in 2008, GWASIS had just started up, and before this consortium was founded, there were only 19 loci identified for lipid-related traits. Over the 15 plus years that GLGC has been operating, we started with the first paper in 2009. We found 30 loci in the first paper. We were very fast. Within a year from the first paper, we were suddenly up to 95 loci, and kind of like regularly updating the data set that we had at hand, obviously meaning in this case having more collaborators joining the consortia and therefore increasing the sample size. We have been able to increase the loci identified up to the 900 lipid associated ones in the latest paper in 2021. This last paper also was followed by two different more methodological papers going into the deeper biology behind the loci. So kind of like as a historical view, what has happened between these different rounds of GLGC. Obviously, in the beginning, the sample size were fairly modest, from 20K to 100K, which actually can nowadays be beaten by a single biobank, let's say it that way. Obviously, all the data was from the European ancestry. So first, non-European samples were included into the GLGC around 2013. But when we look at the last line, which was the 2021 paper, we can see where we're up to 1.6 million samples. Obviously, with this amount of samples, we were able to identify 900 loci, and kind of like where we can already see that we can improve a lot is the diversity part of the GLGC. Like nearly, 1.3 million out of 1.6 million were European white samples. So basically, the next round that GLTC is currently working on is kind of like building up on these lessons we have learned throughout the history of the consortium. First of all, obviously, as Ben said, we should be always increasing the sample size. So that's what we're doing. We're also increasing the sample diversity, so trying to enrich more onto the non-European ancestry samples. We are using the largest imputation panel to have better coverage of the genome in general, but we're also, for the first time in the GLTC history, including whole genome sequence sample sets into the meta-analysis. And last but not least, we are not doing a GWAS, we are actually doing a GWIS, which in this case means a genome-wide interaction study instead of association study. Obviously, that will come as a kind of like an extra side effect. We will also get the marginal effects, and we will get the normal GWAS out of the same results as we're going to get the interaction effects from. And we're looking at the interactions between the genotypes together with age and BMI on the lipid levels. The MGI is part of this, and the analysis was run by Erin Hill-Burns, just to acknowledge that. So kind of like how these big consortia work in practice. So kind of like looking at this latest round, during the whole last year, we were developing and testing the analysis plan. So this is not, these are not fast processes. Like, it takes a lot of time to get an analysis plan that actually works across different biobanks, different traits, can be run in all different kinds of computational systems, allowing for different kinds of setups of data. So in our case, that part took about a year. Then we sat down at the end of December, shared the analysis plan for the collaborating groups across GLTC, and then we had a big call on January, going through the analysis plan in detail to explain why we're doing what we're doing, and we were also collecting feedback and ideas or concerns that people might have. We also ran office hours for all the analysis people or analysts in these different consortia to allow for questions or concerns that are related to their specific data sets. And finally, towards the June, I guess it kind of ended up being end of June and early July when we actually had the data freeze that we wanted. We finally had all the results from the different study sites. So kind of like to give an overview, where are these data sets coming from? So we have put them on the map so that you can see that we are truly a global collaborative project. Obviously, there are areas on this map where we wish there was more dots, like South Americas, Africas are definitely underrepresented still, same as with the Middle Eastern areas in Oceania. When we look at the distribution of these different sample sets in our latest collection, we can see that we're finally starting to decrease the amount of Europeans in proportion to the other ancestries. We do have a bit more males than females in our study set. It's mainly due to a couple of large data sets having a very high proportion of males. But we do have sample representation from 6 different major ancestry groups. And to kind of look the same in numbers, well, first of all, we are now up to 2.5 million samples in total in this genome-wide interaction study. We have completely new ancestry group compared to the last round, which is in the Middle Eastern group. But most notably, we can see that the proportion of Europeans is going down, which means that everything else is going up. So we are definitely increasing our ancestry diversity. Same as a figure, because figures are always nicer, and they kind of show the kind of like the increase, especially in the latest 2 rounds, where we can see these large biobanks starting to emerge. That kind of what Ben was referring to. So these biobanks with hundreds of thousands of individuals added in, the jumps in the sample size have been very drastic in the last 2 rounds. So in practice, this was done using 2 different analysis software, GEM for the unrelated or MGI for the related samples, using GLM models to adjust for the critical relatedness. And most of the samples were using TopNet imputation. Some data sets that were of a certain ancestry were using their own population-specific panels. So in practice, we got the results. We let everybody know when we got their results or if they were okay. We went through their phenotype summaries to see if everything was in order compared to the other biobanks. If there were, wrong unit transformations, and kind of like a basic first QC step. The actual QC for the results were done by Yushan. We're looking for variants with very bad imputation, low call rates, low allele counts, and so forth. But kind of like to note that we are processing over 4,000 files just to get all of this done. So these are coming from multiple different studies, from multiple traits, 2 different interaction terms or exposures, and also for males, females, and then for all jointly. So it kind of results in a lot of files we're going through. We're also going to run an advanced QC where we're going to look at if the allele frequencies are deviating from the expected allele frequency based on the assigned population group. And finally, there's going to be the meta-analysis, which will be done using Mr. Makeup, which is an ancestry-aware meta-analysis software. And kind of like a sneak peek, we do have like the first preliminary meta-analysis run for Europeans only, for joint males and females. So this is just to test out the meta-analysis pipeline, and only for the adults. And the results are very promising. So we are seeing significant interaction effects for all the phenotype combinations that have been run through. Okay, jumping into the other one. So GBMI, Ben already kind of took this one out. So we currently have a bit over 2 million samples with genotype data across these different biobanks that are part of the initiative. On the first round, I want to kind of like point out that there's MGI actually had their own paper on this round regarding the data collection and the setup of the cohort. So very active participant of TBMI. We have a new analysis round starting up pretty much this year. So we had a kickoff meeting in April where we divided into 3 different working groups, all by all, which Ben already kind of mentioned, that we have a longitudinal working group and social determinants of health working group. All by all, led by Ben, Mark, and Wei, are aiming to test every fee code across every biobank in a very organized manner to get a large resource that can be used across the research community. Will be done both 6 stratified and 6 combined to allow for different kind of downstream analysis. Then there's the social determinants of health working group that are working to harmonize, or how to harmonize, I guess is the better question, how to harmonize the social determinant of health variables in these different biobanks coming from different countries, different ancestral backgrounds, and obviously also there's different sampling methodology behind this, like some are hospital-based, some are population-based, so the variables that are available are very different between the biobanks. And then there's the longitudinal working group, which is led by Wei Shou and me, where we're looking for time to event phenotypes. So basically, we are running, instead of having a certain cut point in time where we have yes or no, we have a disease. We're looking at the whole cascade of the events that are happening around that disease. Like, for example, in practice, the prevention would be happening before the diagnosis. A lot of the therapeutic targets are targeted towards after you get a disease, you're trying to somehow manage it afterwards. So time to event phenotypes are basically looking at whether you have a disease or you don't yet have the disease. So there's also that time component included in the model, which is then done using survival models. Obviously, this is allowed by the time-stamped EHRs that are available in most of these biobanks that are part of GBMI. So examples of what kind of phenotype we can be looking for, we can look at from certain disease to a complication. We can look from a disease diagnosis to an operation, even from one diagnosis towards like what's the mortality and how fast the individuals end up dying after a certain disease. But we can also look at how we're moving between different diseases like cognitive impairment to dementia or Parkinson's to dementia. But there's always the time is one of the components in the model. Pictures are not working, or they're actually very small. The dots are not super big on this one. Way has a software, or has developed a software that is actually able to run this in practice. So this one is called Gate, where it is similar to Sage. So it is adjusting to the same issues with cryptic relatedness, but it has the time component mixed into the model, and in the original or the first tests, it is shown to be more powerful for the time-dependent phenotypes. So, as a summary, we're growing. Like all these consortia are steadily growing, kind of like what Ben said. But also on top of just doing GWAS with larger numbers, we are now achieving the sample sizes to start also trying out different types of analysis, like interaction or longitudinal phenotypes. And the sample size increase has been most notable in the non-European samples, which is kind of what the scientific community has been demanding for, and what I think was said that MGI is also driving for, to get more diverse samples into the data sets. But most importantly, these consortia only exist because of the active collaboration between the different biobanks and cohorts. Like these would not run if we did not have the research groups and data sets voluntarily running analysis for us. So with that, I end my presentation.